We're excited at Made in Space to work with NASA and CASIS to use the ISS National Lab. Made in Space fiber optics is a payload to manufacture Z-band glass fiber in microgravity. It will produce hundreds of meters of very, very high-end optical fiber. Manufacturing fiber in microgravity has been theorized to increase the performance by creating a better product. And by better product, I mean a clearer, more pure glass. And that is due to the microcrystal formation. It makes the glass a little cloudier when the crystals form here on Earth. And in space, it'll be more pure and clear. And in microgravity, they form in a different way, in a more pure way with fewer defects. What could happen is
Research on technologies such as fiber optics is just one part of the science mission on the International Space Station. There are experiments underway in many disciplines, including human life sciences, plant biology, space physics, and others. One thing that all of these experiments have in common is that they are taking advantage of a condition on the station that can't be replicated on Earth: microgravity.
An out-of-this-world research lab. Presented by Science at NASA. Every now and then when the sun sets, a bright light appears on the western horizon. Gliding silently overhead, it is the biggest spacecraft ever built by humankind, the International Space Station, or ISS, carrying a precious cargo of astronauts around Earth. But the ISS is more than just a bright light in the night sky. It is also an out-of-this-world research laboratory. The interior of the ISS is furnished with laboratory equipment and chambers for experimental research. It's not as large as some Earth labs, but it has one thing that Earth labs do not: microgravity. Gravity influences everything that happens on Earth. It's hard to envision what life would be like without this force, yet removing the pull of gravity can be uniquely instructive. Reduced gravity provided by the ISS is a major attraction for researchers, says Joseph Nugget of NASA's Johnson Space Center in Houston, Texas. The weightless environment allows scientists to gain insight into basic phenomena in many fields. For example, says Nugget, we all have seen that roots of plants grow down into the Earth. Is this because of gravity? Experiments with plants on the ISS can tell us. Understanding how roots grow is directly applicable to space exploration. What does NASA need to consider when designing a plant chamber for food or life support in space? Farmers on Earth are interested too. A deep understanding of roots can help scientists design hydroponic chambers for agriculture in areas with poor soil conditions. Since the first modules of the ISS were launched in 1998, up until 2017, more than 2,400 investigations have been undertaken by over 3,400 researchers in over 100 countries. Astronauts have spent more than 36,000 hours helping run the experiments for scientists back on Earth. To date, more than 1,600 scientific journal and magazine articles have been published reporting the results. It's a scientific bonanza. There are 5 major research areas on the ISS: biological sciences, such as the root experiments, physical sciences, space science and fundamental physics, human research, and earth science. Nugget has favored examples of each. Scientists grow crystals on the station to discover new crystalline forms. Protein crystals grown in small chambers on the station reveal information that helps find new, novel ways to combat disease. The space station is also equipped with furnaces that can melt solid metals and alloys. This can reveal the metal's crystalline structure in a new way and give greater insight into the properties of the material. While protein crystals are a biological science, and metal solidification is a physical science, both are examples of how crystalline structure develops in microgravity differently than on Earth. Switching over to fundamental physics, he says, there are several investigations on the ISS that examine fundamental laws of physics and continue the search for theoretical particles. The alpha magnetic spectrometer, for instance, provides valuable data on the existence of dark matter. Human research is also very interesting and dynamic, helping NASA get astronauts ready for deep space exploration with many spin-off benefits for people on Earth. Nygett notes, research like the lighting effect study helps improve our flight team's productivity on the ISS and on the ground here in Mission Control, as well as the many American workers who work on night shift or alternating shifts. One-year missions to the ISS return much information about how the human body adapts to space travel, from the genetic level to how the astronaut deals with the long-term isolation within the spacecraft. Not all research conducted on ISS requires reduced gravity, he notes. For example, the ISS is a great place to observe the Earth. The station passes over the vast majority of the Earth's populated areas. Sensors and cameras on the ISS can contribute to disaster assistance, tracking hurricanes, measuring wind and rainfall, as well as documenting events such as volcanic activity. The ISS, much more than just a bright light in the night, indeed. For more from the International Space Station, visit www.nasa.gov/station. For more news about science on and around the Earth, stay tuned to science.nasa.gov.
One of the priorities of research on the International Space Station is to learn what we need to know to support future deep space exploration when we send human astronauts out into the solar system. For years now, scientists in NASA's Human Research Program have been trying to figure out the dangers that long-duration spaceflight poses to those astronauts and devise ways to protect them. Some of that work is being done at NASA's Space Radiation Laboratory.
The NASA Space Radiation Laboratory is an outgrowth of Brookhaven National Laboratory's particle accelerator. It utilizes the heavy charged particle radiation beam from various components already existing at Brookhaven Lab to then deliver specific doses, ions, and energies of radiation to the actual NASA Space Radiation Lab itself, with the goal to determine the potential risks to human beings from exposure to radiation during space travel.
The bulk of the radiobiology data that we've collected from the NASA Space Radiation Research Laboratory has really helped us establish our space permissible exposure limits. NASA has a set of limits that helps protect the astronauts not only from the short-term effects of radiation, but also the long-term health effects. In order to establish what those limits should be, we have to understand how space radiation is different than terrestrial radiation. And the experiments at NSRL has helped us establish our permissible exposure limits in terms of protecting the crew from the risk of radiation carcinogenesis, and also setting non-cancer career limits to the brain for central nervous system effects, and also to the heart for cardiovascular disease.
The primary difference with trying to compare what type of radiation dose an astronaut would get on a mission to Mars versus what a person could expect in their day-to-day life over time is that time factor. Now, a mission to Mars, depending on when you go and how the planets are aligned and such, you're still looking at approximately a 2 to 3 year mission. And while that seems like a long time, it's very different than the amount of time that, say, a non-astronaut, just a regular person that has nothing to do with space travel gets over, say, a 70, 80-year lifespan from, say, some radon gas in the home, or from medical tests that are administered where you get a certain amount of dose from CT scans or PET scans and X-rays through the course of life. So you're delivering a certain amount of radiation dose in a more compressed period of time than you would to the person that has never been a space traveler and such. And that's one of the trickiest aspects to trying to determine radiation dose. The same amount of radiation dose delivered in a day is very different than that same dose delivered in 3 years, even though, well, it's the same dose. It's not that simple, and that has to be evaluated when you try to determine the potential risks of absorbing that kind of a dose.
than half of American astronauts experience some vision changes and anatomical alterations to their eyes during and after long-duration spaceflight. Stuart Lee, the lead scientist for the Cardiovascular and Vision Laboratory at NASA's Johnson Space Center in Houston, explains the current on-orbit investigations of vision impairment syndrome, in which scientists are studying changes in the eye's structure and function. The results of these studies may improve our understanding of how blood pressure in the brain affects eye shape and visual acuity, and that could benefit people suffering from increased swelling and pressure in the brain, or those who are confined to long-term bed rest.
The nice thing about the One Year Twins mission is it brings a lot of high-quality researchers together to look at a very specific problem. It gives us an opportunity to look at the human body in a very detailed fashion that we haven't done before. We're also now looking at this vision impairment syndrome. It's hypothesized to be secondary or as a result of this headward fluid shift that crew members experience during spaceflight. So we're looking not just at the cardiovascular system in our laboratory, but we're also now looking at the eye itself, how it changes in its structure and its function. There's a strong cardiovascular component, so how much of the blood and the blood pressure gets transmitted to the head, which would be different than what's on the ground. The person that goes to see their doctor every day will have a potential benefit from what we learn in looking at our astronauts. Some of the issues that we're looking at for the one-year mission are things that people would normally experience on Earth. These sorts of physiologic changes or adaptations that we've observed and are observing now are ones that we would expect for people who are on for a 6-month transit mission to Mars. So we always stay busy. We always try and keep asking new questions, things that we think will benefit both our crew members as well as the general public.
Orbital debris poses a risk to all spacecraft in Earth orbit. The International Space Station is getting a new